Great morning, guys. Friction is on the plate for us. Now I'll want us to quickly run through what we'll be talking about today. We will start with static and kinetic friction. Then after that we will go straight to the coefficient of friction, then move to the horizontal planes and inclined planes, and then finally we will do the examples that are in line with this topic. I've written down some definitions for you guys so that you may read them, make sure that you understand them, because we'll be basing what we are doing on these definitions. Get a great time while studying them. Please pause the video whilst you are doing that. I hope you paused and studied them. If you didn't, pause now and study them. Take them down if you need to. Just make sure you do something that will make you remember them when they are needed or when we are applying them. So I'm giving you the second chance to pause now and study them. Let me use these images to show the difference between the angle of friction and the angle of repose or the angle of rest. Given this block with all the forces that are acting on it, if you notice, if you can complete the parallelogram method to find the resultant force, then the angle that will be between the perpendicular force, not the parallel but the perpendicular force, and that resultant is what we refer to as the angle of friction. You should also note that this angle can be in any quadrant. It doesn't have to be on the second quadrant as you are seeing it on the board. Now we can move to the angle of rest or the angle of repose. What about it? Let's take a look at this diagram. In this image we have 4 pictures of the sawdust being taken out of that container. The major question is that why it didn't take the shape of the container. Instead, it formed a conic type of a shape. Why? The answer is simple. It's because of the angle of rest. As seen in this picture, if you can add another grain of sand, it will definitely roll down the slope, and that is because it will exceed the angle of rest. I hope that's understandable. Now let's move to more theory part. Please guys, pause the video, read them. These are the advantages, the disadvantages, and the applications. Make sure you understand them, you read them, you pause the video, you take down the notes that you need to take down. If you have to memorize them, memorize them. This is theory. You have to know it because we will be dealing with things based on this theory. Welcome back. I hope you did what you were supposed to do. Now there is this short definition of the coefficient of friction. It's just the horizontal force over the vertical force, or you can even say it is just the parallel force to the plane over the perpendicular force to the plane. If, for example, you move, slide, drag, or even push a mass as seen on the diagram, you should expect some resistance caused by friction, and this is the formula for the coefficient of friction. Now let's move to this block and label it. I know you're not seeing this for the first time, but for explanation purposes you need to again see it and understand the concept behind these arrows. We all know that this block is in equilibrium, and we know that NR and W or mg, they are perpendicular to the plane, whereas F mu and Ft are parallel to the plane. So we will use the formulas we have for equilibrium. From this diagram you should have noticed that LA is equal to F, which is our frictional force, and AC is equal to R, which is our reaction force or just normal reaction. When we follow these steps, this will only lead us to one conclusion, that the tan of the angle of friction is equal to the coefficient of friction. This is how we get these formulas. So I hope you do understand how we got about them. Also notice that our FT is parallel to the plane while NR is perpendicular to the plane. From the previous information, let us again label this block and see how we come about it. If from this block you notice that FT is not parallel to the plane, then that means we should resolve FT into components, vertical and horizontal components, or parallel and perpendicular components. The moment you resolve our FT into components, even if you can remove it, it no longer has any effect or impact. So in other words, you can just remove it and leave it out of this so that you may not be confused. The reason I said that you can remove it is because I wanted you to understand that now we no longer have an angled FT. Instead, we have two components that are either parallel to the plane or perpendicular to the plane, not FT that is at an angle. Knowing the fact that this block is in equilibrium, now you can use what you know to fulfill our well-known formula. Just to make sure that we are on the same page, let me run through how did we get these formulas. NR is going up and also FT sine beta is going up, so that is why we have them under the up arrow. And W, which is mg, or the weight, is going down. That is why we have mg on the other side of the equal sign. Same applies for the parallel forces. Ft cos is going towards the right hand side, whereas F mu is going towards the left hand side of this block. Another thing I should clear out to you are these terms pulled and pushed. What are they? These will be the keywords that you will be looking for on the question paper. For example, on the one that we are dealing with now, it's pulled up. It doesn't matter whether it's pulled up on the right hand side or on the left hand side, but as long as you see the term pulled up or drawn up, dragged up, whatever term, but you will know that this will be the formulas to use in order to calculate for your FT. Assuming that they are asking you to find FT, as you can see, FT appears on both of our equations. In other words, we need to make FT the subject of the formula. How? By first following our mu equation, then make FT the subject of the formula. Similarly, for the pushed keyword, we will follow the same for our block, same steps for everything, for the components of our force that is being placed at an angle, and also for our formulas of equilibrium. We will follow exactly the same steps all the way to finding our FT and making FT the subject of the formula. Here are the few things that you may also notice on top of everything that I've said. F mu, as F mu is a frictional force, it always opposes motion. That means F mu will always oppose the parallel component of your force. That means Ft. So as you can see, Ft cos beta is always parallel and also is always opposed by your F mu. That's all for now. I think you are done and you are fine with this section. We can quickly move to the next point. Guys, if you have any questions, please do not hesitate to ask them, because I'm here for you. I need to answer your questions because I want to see you pass.